All right, so I am Sean Middleditch, and welcome to my talk on spaces. This is the season finale of Game Engine Architecture Club until the next semester. So hopefully this will help you guys prepare for all the work you're going to be doing the following 4 months. About myself, for those of you who don't know me, my name is Sean Middleditch. I am a senior at DigiPen in the RTIS programming degree. Founder of the club, worked on a few games you may or may not have heard of. Currently employed in the industry, loving it quite a bit, so I'm sure you guys will too. So this talk is about spaces, specifically what spaces are, what they're used for, and give you some hints on how you can implement them, both in a new engine from scratch or how to kind of get them into an existing engine that wasn't originally designed for them. All right, so what are spaces? To understand what spaces are for, I'm going to step back a minute and talk about game engines that don't have spaces. So game engines typically have a level, and then they have game objects in this level, where a level might be in a classic mission-based game. You have your first level, which is maybe, say, an old warehouse, and your second level is maybe a factory. And you're moving between these distinct areas in your virtual game world. So all the game objects are organized based on the level they're in. If you've got an enemy who's in that first level, then you're not going to be loading enemies in the second level in order to update the state of that first enemy. When you go to the second level, you're going to unload all of the enemies you had in your first level. So you're either in one level or the other at any given time. There's no sharing of game objects between these levels. So there's a lot of different ways that you can try to handle the transitioning between levels. When you leave one level, how do you decide which objects to destroy? You can say you're going to destroy all of your enemies in the current level, but you might have other objects that are persistent. Things like the player. Do you destroy the player and recreate the player? Do you transition the player from the old level to the new level? And this matters depending on where you're going to be storing things like your player's current health and what weapons he's picked up and other power-ups. There's lots of different ways to handle all this. And it can be kind of messy in current engines. There's also questions like menus, for instance. If you open up a menu and your menu is actually implemented in your game engine, then your menu is game objects. So if you're opening up a menu and then you have to then close that menu, how do you figure out exactly which objects are part of that menu and which objects are part of your level so you know which objects you need to clean up and destroy? So these are a lot of the kind of problems you're going to run into without having spaces. So yeah, going into the menu example a bit better here. If you've got a pause menu, you're in the middle of a level, you've got 3 enemies loaded, you hit the pause button, a menu pops up, and you've implemented this with game objects. You have a game object to represent the menu background and the menu buttons. When you close that menu, what are you going to do in order to get rid of the menu? And an even more complicated problem is how do you stop the game objects in the menu from interacting with the game objects that are in your level? If you have a 2D game and you want to have a little bit of physics to your menu so they kind of bounce and jiggle around maybe, you've got this issue now where your enemies are using physics and your buttons and your objects in your menu are using physics, and you don't want them to collide. So your physics engine might have ways of masking objects apart from each other. So you might have menu objects separate from enemy objects, and they're set up so they can't collide. But what now happens if you go into your pause menu, and then you can open up an inventory menu, and you want it so that it's see-through, and you can see the pause menu behind it. Now you're back to the case where you've got these objects that are both set to be menu, they're colliding. There's all kinds of different ways you can try to solve this problem, but they're all messy, they're all complicated, and if you don't think about them up front, you're going to run into them and get bit by them. So there's a few different solutions we go with here. One of this would be to have a menu system object that just tracks all the game objects for the menu. So you've got some kind of system somewhere, when you open up the menu, it creates all the game objects for the menu, all the buttons and backgrounds, and registers them somewhere with a list of game objects. So you know that when you close the menu, you just iterate over all the objects in that list and destroy them. One problem with this is that it's error prone. You have to remember to actually register these objects from the menu with this list. And if you're creating new objects in your menu, like you have particle effects that are flying around in your menu because you have these really fancy interactive menus, you got to make sure that those are getting registered in the right list and that any particle effects that are running in the game aren't accidentally getting registered in the menu when it's open. There's all these little problems. They're very error prone, and it's very easy to get something wrong. And then there's also the issue with separating interaction between the game objects. You're going to have to rely on lower level facilities like physics masks and other things that are, again, just hard to keep track of and hard to enforce when you're actually managing all these different game objects. So a second approach would be to use a tag or a bit mask for your goes, which is very similar to what I was saying for physics engines, where you have this, this layer mask for physics. So it's Box2D and pretty much all the physics engines support to some degree. You can move this into the game object itself. So at this point, you can say, when this level loads, all objects in this level should get tagged with the bit that indicates this is a menu object. And then when you want to clean up a menu, you just say, delete all game objects that have this particular bit. This is going to run back into the exact same problem before with bits, is the fact that now your pause menu probably should have a separate bit than, say, your help screen menu, because these might be open at the same time, or your inventory menu. And then you're also going to need possibly separate tags for different levels when we get into some of the other cool tricks you can do with spaces that the system can't handle. So when you only have 32 bits, it's not a whole lot. You're going to run into limitations here. For very small, simple games, this approach might work, but it's not really going to be flexible and extendable to larger, more complicated games. All right, so a third possible solution is to just put objects at wildly different coordinates in the game world. So if you have a pause menu, then you say, I'm going to load the menu so that all of its objects are at X position 20 million, and everything else is at position 0, or close to position 0, 0. So that way you know that your objects aren't going to interact with each other, and you can just have two cameras drawing different areas of your world, and they end up being drawn on top of each other properly. This sounds really sketchy, but I have actually seen this in real, actual shipping games. I've had to work around all the bugs that this causes in at least one game. This solution is something people do when they don't have spaces, because they are trying to keep their objects totally separate from each other, and the only means they have for doing that is their position coordinates. We don't want to do this. This is exactly the kind of problem that Spaces seeks to solve. So the actually accepted solution that we're going to call Spaces is that we create a collection for game objects. Each game object belongs to a particular collection. And this is almost kind of like a namespace for game objects. A game object belongs in one collection and one collection only, always belongs to a collection. Whenever you create a new game object, you have to tell it which collection it's being created in. It's because each collection is fully independent and isolated from each other, all the objects are in one collection or another collection, you can guarantee yourself that there won't be any interaction between these. If you have two spaces, and you have game objects in one space and game objects in another space, physics cannot interact between these game objects. Graphics cannot interact between these game objects. They are completely isolated from each other. So again, if you have menus and your actual level, you can load your menus into a separate space. Then your core logic can say, well, draw the actual normal game world, tell its space to draw itself, and you can tell the menu to draw itself, and they'll draw on top of each other. But there will be no interaction at all. There's not going to be any physics collision going on. And when you decide you want to get rid of the menu, you've got this handle to the space you created for your menu, and you can just tell that space to delete itself. And it deletes all the game objects inside of it, and everything is cleaned up properly. If you have game objects that spawn other game objects, like the particles we were talking about, because every game object must have a space, your logic is going to be intrinsically written such that when you spawn a game object, you're passing the space of the object doing the spawning. So if you have a button that you click and it creates particles, you say, when I create this particle system, here's my space to create this object in. And you're going to guarantee that all these objects stay organized properly where they're supposed to be. It's a very simple concept. These are just containers. You put game objects in them, not a whole lot to it. But it helps conceptually solve a lot of problems without requiring a lot of machinery. So yeah, we call these spaces. Note that spaces are not a formal term. You will probably not find this online if you're looking for this term. Professor Chris Peters created this term. I first heard it from him. That's what he's been using in a lot of his work. There are other game engines that use a similar concept, but they're all named different things. I don't know of any particular standard term for this that is easy to Google by any chance. So again, the basic idea is when you load a new level, you create a space just for that level. This is just an object. It's a container. You create the space, load the level into it, and there are all of your objects. When you're ready to unload the level, delete the space, everything for that level goes away with it. And again, menus, same kind of thing. Just go ahead and load up each menu in a different space. If you have a pause menu and you have a inventory menu, you create a different space for each of them. Now there's no conflicts. There's no need to even worry about physics masks or worry about any other way of controlling how these things interact. They are completely and totally separate. You can still draw them on top of each other. That's up to you to control. We'll get into that in just a bit. But another nice thing is that when you have spaces, you can just turn off a space. So if you load up a menu and you're thinking, well, I don't want to have to load up the pause menu off disk every time I decide to pause the game, you don't have to do that. You can just load this pause menu and all of its game objects into a space and just toggle that space on or off inside of your core engine loop that decides which space is in order to run and execute and draw. So that way you can easily just say, hey, I've unpaused, turn off the pause menu, and you're running again. Not a whole lot of work. And it just helps organize a lot of things that is normally just kind of cut and paste it all over the place in your engine if you're not using a nice concept like this. So another concept with spaces is the concept of a subspace. A subspace is it's a space version of a system in a traditional engine. So a normal engine, you would say, I have the physics system, and I have the graphics system, and I've got the AI system, and possibly a few other systems, input system, things like that. The idea of a subspace is it is the system moved into the space itself. And this goes into how we separate objects from interacting with each other. If you have a single physics system, your game objects generally register themselves with the physics system, and it tracks all the bodies and keeps track of collisions and movement and all things like that. And this is why they will always collide with each other. They're all sitting there managed by the same thing that's looping over all the objects together. If you move this system, or at least that logic, that kind of logic into a subspace, so this list of which physics bodies exist is now per space rather than global to the engine, this is what makes it so that your physics objects aren't colliding with each other between other spaces anymore. The same thing's going to go with your graphics. If you're registering all of your renderable objects with the central graphics system so it can do efficient batching and sorting and rendering, you do it per space. That way you can do also tweaks per space. So you might want to say that you have these two spaces that are active at the same time but have different properties. We'll get into some neat tricks you can do with that in a bit here, but it's really valuable. If you're going to use spaces, it should not be just a collection of game objects. It also needs to be those other collections of components and logic that are going to be that need to be separated in addition to the game objects themselves. So if you think about a traditional component-based game engine, components are just, or subspaces are components for the engine, essentially, or components for spaces. All right, so what actually can you do with spaces besides just organizing objects in your game scene? So the basic case is organizing your objects. One of the cool things you can do is have different physics properties. Right? So you might have two different levels, and you want to have different gravity for each of them. One, say they're on two different planets, so gravity is weaker on one and it's stronger on the other. If you just have this global physics system somewhere that has a gravity setting, you're going to have to have some kind of script that remembers to run that when you enter this level, set it to this particular gravity, or pull some data from the level, put it into the physics system. And then if you're trying to run two levels simultaneously, which say you're doing a split screen game where two players can be in two different areas, now a global system is not going to work at all. You need to have these separate areas for each of the players. You want separate physics properties for these global physics properties. Putting these on the subspace instead of on a global system now lets you easily separate these things and have separate configurations for different parts of your game, even when they're running simultaneously. Another neat trick would be network testing. I know someone here at DigiPen who did a project based on this. The simple idea is that you can have, instead of having to run two separate full clients, you can create two instances of the game running inside of your engine in a single instance and have them talk to each other over the network protocol without actually having to go over the network itself. So you can easily set breakpoints and do debugging and understand that both instances of your client are going to be stopped at the same time as there's a single breakpoint, single application. Everything stops. You can also very, very easily insert tracing and logging into the network layer here and see exactly what's going on and debug things in your protocol and debug some of the hairier parts of networking aside from the actual dealing with latency and the other parts that you really need an actual network to test. It helps a lot. It can really help solve some problems, especially earlier on in your testing. A really cool feature is doing in-game editor support in a really fancy way. The idea here is, let's say you have a blueprint in your game. So this is a definition of all the components and settings for an object. Like, for example, you have let's say you're building a new Mario game with a component system and you've got Goombas. So you need to have your Goomba archetype. So you've got this data structure that defines all the properties and how you're going to create an actual instance of a Goomba in your game. The problem now is that in order to edit this instance, you need to have an editor for your blueprint itself. And this is kind of annoying, is now you've got to have an in-game editor to tweak properties of an instance of a Goomba and a way to edit the blueprint for a Goomba. So maybe you think you're going to use object cloning. So the idea here is that you actually just create a Goomba in memory, and you can edit that and tweak that, and you just make a copy of that. But then now this makes problem if you want to render a preview of this Goomba in your editor. You want to pop up a little window on the side that can render it. If you have to create an instance of this in the world, give it a position, and actually render from a camera, how do you make sure you don't accidentally render other copies of it? You can do that thing where you move the object way out in the middle of nowhere and try to render it from there. Again, I've seen that happen. It doesn't work out too well. There's just a lot of different ways people have tried to solve this, and they're all very error-prone. A very easy way to do this, however, is just create a new space for your editor. Whenever you want to edit an object, you create the instance in this space. This space now gets its own viewport. You can just render that space and that space only in the viewport. even if you aren't using object cloning, and you've got the separate data structure for blueprints versus object instances, when you want to edit your blueprint, you can spawn the blueprint as an instance into the space. Do all of your editing using the shared editing code you have for object instances in your game using ant, tweak, bar, or whatever inspector you have. And then when you're done, serialize that back into your blueprint, and it's right back there in your original data structure. Because you can do this creation of an actual live editable instance of your object in a space where it's isolated, it just makes it so much easier to use a lot of the same code and the same techniques to get everything done. This will actually just cut down large amounts of code in my experience. This is absolutely the way I think you should go if you're going to be doing an in-game editor. There's also some neat tricks for using isolated levels. One of the things that we looked at before is we wanted to have a 2D platformer where in the background, off in the distance background, there'd be enemies moving around or NPCs moving around or some kind of action going on to give life to the world. There's something going on besides what the player's doing. So these, in a 2D game, your players can be walking right through some of these guys because they're off way in the distance. We don't want them colliding. We don't want the AI to be able to see each other and have something way off in the distance think it's trying to chase the player. We want them to be completely isolated, even though they're being rendered in the same scene. So what we did here is we actually just created multiple spaces for a level. We created one space per layer, as we called it, for the level. So we had the foreground layer where the actual player is doing all of his actions and fighting the enemies and moving around, collecting power-ups. And then we had the background layer. And there's all the enemies, other enemies moving around and crawling around on walls. And it looked just like the enemies that you would see up front, but distant. And it just made the world feel more alive, gave it a little bit of depth, even though it was just a simple 2D platformer. You can also use this in more complex kind of games, 3D games. You say you have a top-down isometric view, and your player can say, go from an outdoor area into a house. Games like Neverwinter Nights would do this, or a lot of other RPGs. So you could use a different space for the houses, because usually when you go in the house, you transition, you're in a different area. This makes it possible for you to have the entire game, the outdoors still running. For example, a multiplayer game where you're running the server, and you have a player who's outside and a player who's inside. You can use this to help you organize your game objects and make sure that what's going on in this house doesn't interact with anything going on outside of the house, even though they might be at similar coordinates or otherwise. Otherwise, just looking without spaces, you might have a lot of problems making sure that there's not unintended interaction between objects. And honestly, there's tons more use cases. I have not seen any of the commonly available AAA game engines use this technique. Just a lot of homegrown engines. So there are probably all kinds of cool things you can think of to do with spaces that nobody's done yet, because they're just not a mainstream concept at this point. So by all means, if you think you've got an idea that spaces might solve, try it. There's a good chance no one else has, and we can't tell you if it's going to be a good idea or not. And you might very well come up with something cool that's going to help other people out in the future. Something just moved. All right, so making spaces, getting them implemented into your engine. So the first thing, I said before, is you have systems and subspaces, and you're really going to want to move as many of your systems or large chunks of your systems into subspaces as possible. So if you have your physics system, you're going to want to break that out into a physics subspace that you can attach to your spaces. You can convert most of your systems into subspaces. Some things like input might not necessarily make sense to have a subspace. I wouldn't know what two different subspaces input systems would do differently. It's kind of more of there's only a single user input state at a time. And there are certainly things that maybe you wouldn't always have in the subspace. For example, if your graphics system is managing resources like your models and textures, you don't want to duplicate those between each space that you're running. So you're going to still want to have a global graphics system or global resource system that are managing things that will honestly be shared amongst all spaces. But anything that's going to manage actual game state, physics system has all the physics bodies in their positions. Graphics system can certainly have a lot of information about the scene that it's trying to render. These things can be split off into subspaces and made components of the space object itself. And then for game objects, really the only big change is to actually have them be assigned to a space itself. Usually in a lot of game engines, you have a game object factory. This is another global system. You tell the game object factory to create an object. It keeps track of all the objects that are around and is responsible for cleaning up objects and lifetime management. All this system does is it splits that out into a subspace, or actually into the space itself. It's also possible you might want to have both. You might want to have a game object factory that's global and tracks all objects in existence, and then spaces track their objects as well. There's some possible things you can get out of that when it comes to game cleanup and resource tracking, things like that. But at the simplest level, if you want to use spaces, just move your game object factory into a space itself. So in order to create a new game object, you have to create a space and then tell the space to create the game object, rather than asking the global engine game object factory system to create the game object for you. So the bigger one of the harder things to kind of handle is how you're going to deal with components in a space-based engine. So the idea here is that components originally would register themselves with a system. So you create a new physics component, and it's going to go ahead and look up the physics system and register itself with that physics system. So the body is now in the physics simulation. The big difference here now is when you create the component, it's created on the game object. The component asks the game object for the space it is currently in, and then asks the space for the physics subspace, and then it registers itself there. The tricky part is because subspaces are or can be implemented as components, you very well might have a system where not all spaces have every type of subspace. For example, you might create a space for a menu, and since you're not using physics in your menu, there's no reason to create a physics subspace for your menu. So if you then try to create a game object in the menu that has a physics component, and it's going to ask that's the space for the physics system or the physics subspace, and it's not there, what do? Is this an error? Do you fail to create the component? Do you automatically create the physics subspace in the space? I mean, there is no correct answer here. Whatever you feel is correct is the way to go. And one of the correct options is, of course, to just have every space have all of the subspaces. It's really, there's not going to be a whole lot of pain or waste if every space has all of the data structures for managing physics. It's not going to be an issue, unless you're creating a ton of spaces, in which case you're probably doing something a little weird. So when it comes to managing things, one of the things I've seen other people worry about is, I've got these space objects, who's in charge of managing them? There's this concept that there always has to be someone in charge of every object, a system that is in charge of it, some single piece of unified code that can handle all objects of a particular type. That's not really necessary in general, and it's certainly not necessary for spaces. Instead of having a central space system or space manager, we can think of all kinds of cases where spaces might be managed by different systems. If we're using our in-game editor, like I was saying earlier, the editor system might just have a single space that it uses for the object that is being edited. Your menu manager might then have a list of spaces for any menus that are currently open, since we said we could just turn a space off rather than destroying and recreating it. So it has this list that maps the enums for particular menus or string names for particular menus to the spaces that those menus are loaded into. Your level manager then will have a list of spaces for each level. Your individual levels might be made up of more than one spaces if you're using that multi-layering technique I talked about. There is no need for some big central system of unified code for spaces. These are very much, they're like any other container. You don't need a central system to manage all of your standard vectors. You don't need a standard system to manage all of your spaces. The only thing is just to make sure is that you've got your core lifetime management worked out, so you know that when you're done with the space, you actually delete it, clean up all of its game objects. That's really nothing new for most of you. That's really all there is to it. I mean, that didn't sound like a lot, and because there's really not much of this concept. Spaces are a container of game objects. They have subspaces that manage the game state for these game objects. It's very simple to convert an existing game engine to use these. Like you said, you pretty much just add, you add a new pointer to game object for which space it's in. You move some of your data structures for your simulation out of a system into the space object itself. And your components get updated ever so slightly to be aware of spaces rather than being unaware of spaces. And that is pretty much it. You get all that done, you have spaces in your engine, and you can start using them for pretty much anything you can possibly think of. So summary, key points. Spaces are great. They're super easy to implement. They give you a lot of flexibility and power. You should absolutely think about using them. I can't imagine doing another game without them. Even a fairly simple game, they will give you far more in return, or you'll get a lot out of them for how easy they are to implement. They're absolutely not a waste of time. And that's it. Any questions?
For example, when you would implement the spaces and subspaces at runtime, you would have a generic space or space class that has a vector of subspaces.
Yeah. All right, so the question is, one way of implementing be to have a generic space object that just has a vector of subspace components if you're to implement subspaces? The answer is yes. That is a perfectly valid way of doing things. You just have your I subspace interface, and you can just have a list of these. You can look them up. You could also just have raw pointers if you know that you only have 3 subspaces, like a graphic subspace and a physics subspace and an AI subspace. Every space might just have 3 pointers for each of these, and if you're not using one of them, it's a null pointer. It is exactly the same as implementing components on game objects. So whatever technique you're using for implementing components on game objects makes just as much sense for implementing your spaces. If you're looking for a slightly more generic implementation, you might actually separate game objects and components into a composable object interface that game objects implement as well as spaces implement. There's actually there's a lot of places you can use component-based design besides just game objects. Spaces are a great place that shows.
So if all of the gameplay is determined by just what objects you have loaded, then would the equivalent be just to keep like multiple vectors of objects and just switch between them?
Yeah. So the question is, if all of your game state is managed by a list of objects, would it not be equivalent to just have a list of vectors of game objects? Is that correct? Yeah, so that is essentially what spaces are. It's just a slightly formalized notion of that. Any other questions?
So would your core engine manage this list of spaces, or would these spaces be objects themselves? Because I got a little confused when you said the whole object factory could be moved into the spaces. Because I kind of thought of it as the space is a game object, which you said that's one way of doing it. But if that was your way of doing it, where the game object is the space, then would the factory manage that, or would the core engine manage all spaces?
All right, so the question is, spaces as game objects, specifically who manages the spaces in that case?
Yeah.
All right. So if your spaces are game objects, which is a valid way to do it, you might still then have a global game object factory that manages all game objects, especially spaces. Or you might even just have a hierarchy of spaces. If a space is a game object, you could, in theory, have a space that has a game object, which itself has a space. I don't necessarily know of any use cases for that off the top of my head, but you might be able to find some cool things to do with that. There might, again, off the top of my head, I can't think of anything cool to do there. But so, yes, as far as how you manage that, whatever makes sense to you. There is no particular need to have some formalized way of doing that. So if you just want to have a central system that keeps track of all game objects that are spaces versus game objects that aren't spaces, that's one way to do it. Or you just have spaces be a distinct game object from a distinct object that are not game objects. And then that way it gets a little bit more conceptually easier to understand who owns what. You can also just say that not every game object necessarily requires to be inside of a space. And then that way your top level game objects are your space game objects. And then they aren't owned by any particular space. They're just owned by whoever owns them, either a central central space manager if you want to go that route, or individual systems in your engine that manage spaces. Like I said, like the editor might own spaces versus, say, the level manager might own spaces. Right. Any other questions? All right, thank you.